Okay, so let's see if you have the financial and mathematical knowledge to answer this question. All right, let me go and read it to you. It is the following. Can you grow $3,500 into $8,500 in 9 years if you invest this money at a 7% annual compound interest rate? All right, well, you're definitely going to need a calculator to help you solve this problem. But the type of calculator I'm talking about is something like a simple scientific calculator. A lot of you might recognize, oh, you know what? I can go online and plug all this information into a financial calculator. Well, don't use that kind of calculator because I'm really trying to see if you understand compound interest. All right, so if you can solve this problem, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second, and then of course I'm going to thoroughly go over the solution to this problem. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so in a real basic sense, the question is either going to be yes or no, right? So we have this money, this $3,500. We want to kind of make money on our money, which of course is a good idea. So we're trying to turn this $3,500 into $8,500 in 9 years, or maybe even less time, at 7% compound interest. Can this be done? Well, let's go and take a look at the answer. The answer is no. Now, the answer to this question was either going to be yes or no, right? So if you didn't know the answer and you just guessed, well, that was smart because you should always guess, when you have a math question, certainly if you got a 50-50 chance. But let's say somebody said, well, I think you're wrong, and now you have to prove that in fact you cannot do this. Well, this is where you need to back up your answer, justify it with mathematics, and that's the whole point of this video. But if you got this right and you're like, yes, indeed, Mr. YouTube Math Man, I know exactly why. I have all the proof from a mathematical standpoint, then we have to celebrate by giving you a nice little happy face and A plus a 100% and multiple stars. So you can brag to your friends and family that indeed you are a certified professional expert in the area of compound interest. And really, what we're talking about here is something called exponential growth. Exponential growth. Matter of fact, let's take a quick look at this before we get into the solution. Let me just kind of give you some basic concepts here. So let's suppose something grows like this in a straight line. Okay, maybe like a plant or a tree or something. Maybe for every year it goes up a certain amount, maybe 1 foot. Let's say some sort of plant. For every year it goes up 1 foot. The next year it goes up another foot, etc., right? So what type of growth is this? How would you classify something that grows in a straight line? Well, hopefully you said, well, that's linear growth, Mr. YouTube Math Man. Well, that is fantastic. That is correct. But there's a lot of things that don't grow this way. Okay, what about something that grows like this? Kind of starts off slow and then it eventually kind of skyrockets, right? Well, this is an example of exponential growth. And a lot of you probably have heard of compound interest, especially as it relates to investing. Okay, I'm sure all have heard, and it is true that over a long period of time, if you put in like $100 into your, well, I don't know, 401k, IRA, whatever the case might be, some sort of investment vehicle, if you just do this for like say 40 years, you're going to have like $1 million at the end of those 40 years, right? But what happens? Well, what's going on is that it's slowly kind of building up steam. It's, growing kind of slow for a good amount of time, but eventually reaches this kind of critical mass and really takes off. Okay, well, this is an example of exponential growth. Okay, this is exponential growth. So compound interest works in this way, but so does other things like, say, population growth. So, there's a lot of things that have this exponential growth pattern, right? It's extremely important in science and mathematics, and it's absolutely must know for those of you out there that are taking any sort of algebra course. Okay, so this is basically the whole topic of this video, compound interest. But hopefully this little basic explanation gets you excited. And some of you might be saying, all right, Mr. YouTube Math Man, come on, hurry up. Let's go. Show me how to solve this problem. All right, so here we go. So here is our problem. And as usual, with any math word problem, you always want to read it at least 3 times. Okay, you got to understand really what the problem's asking before you make any moves. But here, okay, if we don't understand annual compound interest, we won't even understand the problem. And when it comes to compound interest and interest problems in general, there's all different sorts of interest models that you can follow. You could have simple interest, okay, which there's a particular formula for. You can have annual compound interest, this type of thing right here. Let's just kind of abbreviate this, annual compound interest. This has a particular formula. Then you can have something called continuous compound interest, which uses another formula. Okay, so you got to be able to identify what formula they're going to be using. So I'm going to show you the formula for annual compound interest right now. We'll make sure you understand it. And of course, I just kind of went over the concepts, and then we'll apply this formula to solve this problem. Okay, so let's go ahead and talk about compound interest. So this is your basic compound interest formula. Now, we're talking about annual compound interest. In other words, at the end of 1 year, you're going to get paid your interest. Okay, and hopefully we understand the concept of interest, right? You put in a principal amount into some sort of vehicle, it stays there, and however your interest is accumulating, you can have simple interest or compound interest. At the end of 1 year, you get paid. But that's not the only way you can get paid your interest. When something is compounding, you could have things compound quarterly, biannually. There's all different sorts of rates. But we're going to keep it kind of simple with this particular problem. And I'm only saying this because this is not the only formula that you may need to understand, especially for those of you that might be taking like a second-year algebra course or some sort of financial math. You'll need to know other formulas as well. But this is our basic general compound interest formula. All right, so let's go and see how it works. So we invest a principal amount, right? You go to the bank and you're like, hey, I want to make some money on my money. I'm going to plug in some money or put in some money into my financial institution, whatever that might be. That money that you put in, okay, that you saved up and you're going to invest, that's called the principal, okay? Now, the money you hope to earn, your total amount that you're going to get out, is this variable A. Okay, that's the total amount you're going to earn. So this is going to be your principal plus the interest you make. All right, so the formula is A equals P times, this is a parenthesis right here. Let me go ahead and just remove this stuff. So it's A equals P parentheses 1 plus R. Now R is the interest rate expressed as a decimal. Now, because we're talking about annual compound interest, t up here, okay, of course, notice this is in the exponent, so this, i.e., this is an exponential function. This is the time in years. So, of course, I could have made this problem a lot more interesting. I could have said, can we grow this money in 9 years and 3 months? We're not going to do that. We're going to, because there's enough kind of going on here, but this is the basic compound interest formula that you need to understand. All right, so if you're saying, okay, Mr. YouTube Math Man, I got it. Let's go ahead and use this to figure this problem out. Well, I think that's a good idea. Let's go ahead and do that right now. Okay, so here is our formula. And now we're going to have to match up the information in the problem to, okay, what's the principal? What's the total? What's our interest rate? And what are we looking for? Well, we're looking for time in years, okay? How many how long is it going to take? Now, we would like to see, okay, we hope, matter of fact, let me show it to you this way. We would hope that we could grow this $3,500 into $8,500 in 9 years at this particular interest rate. We just don't know that yet, okay? So we're going to go ahead and actually see how long, okay, using compound interest, it's going to take us to grow this amount of money into this amount of money. It may not be 9 years. It could very well be longer. And of course it is, because the answer is no, we can't do this in 9 years at this interest rate. And that's really what this problem is about. So, really I can kind of rephrase the problem. How long will it take to grow $3,500 into $8,500 at a 7% annual compound interest rate. So our variables here, our principal amount is $3,500, our interest rate is 7%, our total amount here is $8,500, and we're looking for T, or how long, what is the time in years. Okay, so let's go ahead and plug in all this lovely information into our formula. So again, our total amount 8,500, our principal 3,500, are our interest rate, but we have to express our interest rate as a decimal. So this is 7%, and 7% as a decimal is 0.07. So we have to use 0.07, not 7%. This is a real kind of classic mistake that a lot of students make, okay? And then, of course, time in years will be what we're going to be solving for. We don't know what that time is to make this true. Okay, so let's go ahead and plug in all the information here. So we have our amount, 8,500, is equal to our principal, 3,500 times 1 plus the interest rate, 7% as a decimal, 0.07. We are solving for the variable t. All right, so now we're down to 8,500 is equal to 3,500 times 1.07 to the t power. We need to solve for this variable in the exponent. Here we have an exponential equation. How do we solve these exponential equations? Well, you're definitely going to need your calculator. And if you're looking at this, you're like, oh boy, I don't even like this problem because there's too many things going on. But anyways, listen, don't panic. I'm going to show you exactly how to solve this. And this is really important to know how to solve, especially again, if you are taking any sort of algebra course. Okay, now, if you didn't understand the setup, but you want to go ahead and try to solve this problem, well, maybe you want to pause the video and work on this. But let's go ahead and take the next step and solve for t. But before we do that, I'd like you to take the next step, and that is to subscribe to my YouTube channel. Now, I wouldn't ask if it wasn't that important. Yes, indeed, it's a way to, for you to show your support for my channel. And that's certainly, I'm very grateful for that. Okay. I don't want to minimize that at all, but I've been on YouTube for over 10 years. I make these videos because I'm a very passionate educator. Okay. I'm trying to reach as many people as possible. And the way I can do that, okay, or the way this happens is by people subscribing. That tells the YouTube algorithm, oh yes, people like this stuff. So they're going to push out my videos to more people. But my objective is to find people that are frustrated with math. They're just, I hate math. I don't like math. I'm bad at math, especially those people that think they are bad at math or on the verge of giving up. I am trying to find these people because this is what I have seen to be a real tragedy over many, many decades. Now, yeah, somebody might be saying, oh, you're being overly dramatic, Mr. YouTube Math Man. No, I'm not, okay? Because so many people, okay, that I've known personally have changed their whole aspirations in life. So many people, I wanted to be an engineer, but I thought I was bad at math, only to come find out later on in life that, you know what, maybe I wasn't so bad at math. Maybe I was actually good. And that, in fact, is the case. I've seen this happen over and over again. Okay, so whether someone wants to become an engineer, that's up to them. But they should not uh, close any doors in terms of opportunities just because they think they're bad in math. Okay, so if you're struggling in math, what you need to know is two things. One, there are no shortcuts. Okay, so you got to be willing to put in the work. But two, find yourself a teacher that can teach you in a comprehensive manner in a clear and understandable way. All right, so sorry for the long-winded commercial break here, but this is the reason why I make these videos. All right, so let's get back to this problem and solve for t. All right, so we got 8,500 is equal to 3,500 times 1.07t. We need to solve for this variable t. We're solving an exponential equation. Okay, so an exponential equation because the variable is in the exponent spot. Remember, if you have a power like 2 to the third power, this little number up here is the exponent, 2 is the base, the entire thing is the power. Now, if you really need help with this and you're not confused with this math, check out my Algebra 2 course or my pre-calculus course. You can find a link to it in the description of this video. That will definitely help you out. Also, I have a ton of additional videos on my YouTube channel as well. But what we need to recognize is this. When you have an exponential equation, okay, exponential equation, we need to use logarithms, okay? And if you have a logarithmic equation, we need to use exponents because exponential functions and logarithmic functions are inverses of one another. Okay, this is very, very important concept. And of course, I don't want to make this video any longer than it has to be and get into a full explanation of logarithms, but this is stuff that you absolutely need to know. Okay, so what we're going to do here is we need to isolate this base or this power part of the problem, and we want to have a power or an exponent rather, like 2 to the x is equal to just some number. Okay, so right here we have this 3500 in front of this 1.07 to the t power. So we're going to go ahead and divide both sides of the equation by 3500, and when we do that, we're going to get 2.428. Now I did round off a bit here, so that will have an impact on our final answer. So 2.428, this really should be approximately, but I'll just leave it equal for the purposes of this video. So 8500 divided by 3500, 2.428 is equal to 3500 divided by 3500 is 1. So now we have 1.07 to the t power. Okay, so now we need to solve for t, and this is where we get to use logarithms, which are of course so much fun. And if you're not familiar with logarithms, if you look on your calculator and you see that log button, well, that's what logarithms are about. Extremely important stuff in math. But what we want to do here is now take the log of both sides, okay, the logarithm of both sides. And here we have the log of 2.428. Now, you could just go into your calculator. You'll see that this right here is just a simple decimal. It gets a value, but don't do anything yet. Don't turn this into a decimal. But the real key to solve this problem, we're going to take the log of both sides, is we have this t up in the exponent. Well, we have a property of logarithms that says that if we have something written like this, we can take this t and write it and put it right in front of that log expression. So we're going to drop this exponent down in front of the log. This is really the secret here, okay? So now I have a number. Remember, this is just a decimal. Is equal to t times another decimal. Of course, this is log 1.07, but this is just a number, okay? So effectively, this problem is very much like 2 is equal to t to the 3 or something, right? This is just a number. It's a basic algebraic equation. So to solve for t, all I have to do is divide 3 by both sides of the equation. In this case, we're going to divide both sides of the equation by this number here. Okay, so let's go ahead and show you that work right now. Okay, so we're going to divide both sides of the equation by log 1.07. And you would want to write your work just like this. Okay, don't do anything on your calculator until you get down to this step. Okay, and then break out your calculator and go log 2.428 divided by log 1, we put this in parentheses, 1.07, and we'll get a decimal, or get a number about 13.11. Okay, that's what t is equal to. And remember, this is time in years. So that's how long it's going to take to grow this $3,500 into $8,500. It's going to take about 13 years, a little bit over 13 years. So of course that is longer than 9 years. All right, so as I indicated, there was a lot going on in this problem. And don't feel bad if you didn't, get this right, or if you're like, I didn't even learn this stuff, Mr. YouTube Math Man. Well, I totally get it. Now, if you are interested in growing your math skills, just like this investment, right? I have a great new course. You might be interested in it. It's called my Math Skills Rebuilder course. You'll find a link to it in the description below. But I started off by teaching you basic math, basic arithmetic. That's really important to get that foundation down. Then I teach you a ton of algebra, a ton of geometry, even some basic trigonometry, and some basic probability and statistics. So if you want to kind of understand math at this level, check out that Math Skills Rebuilder course. That's a great course. It's a self-paced course as well. But anyways, if you enjoyed this video, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.